Okay students, so before starting today's lecture, that is today's topic polygons and its parts. First of all, we will revise once what were the curves, open curve, simple curve, closed curve, everything. Okay, as I have told you earlier that what is curve? Curve is the result of doodling anything. Whenever you doodle it on a piece of paper like this or like this or like this, whatever you are going to doodle on a piece of paper, these are all what? These are all curves. Okay, but if you are going to lift your pencil, if you are lifting your pencil without lifting the pencil, if I will lift my pencil like this is not a curve. This in blue color, whatever I have drawn, I have lifted my pencil. So this is in total this is not a curve, but if you take it in the parts, these are all what? These are all the curves. So whatever you doodle on a piece of paper without lifting your pen, that will be a curve. Okay, now we will discuss what is a simple curve. Simple curve is that the curve which do not cross itself like this. If I will draw like this, it is crossing itself. So this is what? This is not a simple curve. Okay, if I will draw like this, again this is what? This is not a simple curve. Okay, if I will draw like this, this curve is not crossing itself, so this is a simple curve. This first one was also a simple curve. Okay, so simple curve is a curve which do not cross itself. It can be any way. Okay, now next in our list is what is an open curve. So what is an open curve? Whose starting and ending points are different. So just see, if I will draw like this is what? This is an open curve, and this is simple as well. Okay, this is what? Again, if I will draw like this is an open curve, but it is not simple. So these are two different things. Simple curve and open curve, these are two different things. So open curve can be simple also, open curve cannot be simple. Okay, so this is again, this is what? Starting and ending points are different, so it means this is what? This is an open curve. This is also an open curve, because you can check in all starting and ending points I am marking, all the starting and ending points are different. So all these are what? These are all open curves. Now next in my list is what is a closed curve. So closed curve is a curve which starts and ends at the same point. Suppose I have started from this point and again I'll end at this point. So this is what? This is a closed curve. Okay, now this is what? This is a simple closed curve, because this closed curve is simple also. So if I will draw like this, it start from here and I am going like this, it ends at the same point. This was the starting point and this is the ending point also. Okay, but this curve is crossing itself, therefore this is not simple. So first one is simple closed curve and the other one is not simple but it is closed. Okay, now next in my list is what is a polygon. So as we have discussed earlier, what is a polygon? It is a simple closed curve entirely made up of line segments. So means you need to make a simple curve. Secondly, you have to make it closed curve, means starting and ending points should be same. And thirdly, all should be the line segments in this. Okay, so I am going to draw a polygon here. So again, this is starting and ending point are same. So this is a closed curve. It do not cross itself, so this is a simple curve. Now it is entirely, you can check, entirely made up of line segments as well. Okay, now again I am going to draw one more polygon. I have started from one point and ending at the same point again. So again this is what? This is a polygon. Okay, again it is a simple curve, it is closed also, you can check. It is simple because it is not crossing itself. Okay, it is closed because starting and ending points are same. Thirdly, it is entirely made up of line segments. So in case of polygon, you have to check for the three qualities in a curve. Okay, so now what we have discussed, polygon is a simple closed curve entirely made up of line segments, and the figure below given is a polygon, as it is simple because it is not crossing itself, it is closed also, and it is made up of line segments also. So students, now again there is one important note for you. A circle is not a polygon because a circle is simple, it is closed also, but it is not entirely made up of line segments. Okay. Now next we are going to discuss what are the parts of a polygon. Okay. So first of all, what are the sides of a polygon? So the line segments forming a polygon are called its sides. So you can check in the picture also, AB, this is also a line segment. Again next is BC, this is also a line segment. So these are what? These are called the sides of these are called sides of a polygon. Okay. So AB, BC, again third line segment you can identify, it is CD and AD. These are all line segments forming this polygon. So these are called sides of a polygon. Now next we need to discuss what are the vertices of a polygon. So the corner points where the two sides are meeting each other, those corner points are called vertices. So here you can check point A, point B, point C and point D. So four vertices are here of this polygon. These are the four vertices, point A, B, C and D. These are called vertices of a polygon. Okay, so next we need to discuss what are the adjacent sides of a polygon. So okay students, adjacent means in a neighborhood. Okay, so adjacent sides are those sides which have a common vertex. Okay, so let's see. If you will take AB side and BC side, what is the common vertex here? The point B, vertex B is common in both. Vertex B is common in both. So these are what? These are called the adjacent sides. So AB and BC are adjacent because B is the common vertex. So now next pair of adjacent sides you can take BC and CD. Why? What is the common vertex here? The common vertex here is the point C. So that's why BC and CD are also the adjacent sides of the polygon. Now next pair we can take is CD and AD, right? So what is the common vertex in this? D point is the common vertex in these two sides, CD and DA. So CD and DA are adjacent sides of this polygon. There is one more pair of adjacent sides you can check. Next pair is DA and AB. Again just check what is the common vertex in these two. Common vertex is point A. So common vertex is point A. AD and AB are two adjacent sides. You can give name as you want. It can be DA also, it can be AD also. Okay, so either you can write it like this, DA and AB, or you can write it starting from point A, you can write AB and AD. Okay students, so now if you need to find out what are the adjacent sides of a given side. So if you will take side AB, so just check what are the sides which are neighboring to the side AB. So from point B, BC is adjacent, so AB and BC are adjacent. One more adjacent side to AB is there, that is the side AD. So AB and BC are adjacent and AB and AD are also adjacent sides. So similarly you can check from the table given here, sides adjacent to AD. What are the sides adjacent to AD? From point A it's AB and from point D it's DC. Okay, so similarly you can check for others also. So these were all about the adjacent sides. Now next is we are going to discuss what are the opposite sides of a polygon. So opposite sides of a polygon are those which do not have a common endpoint or which do not have a common vertex. Okay, so if I will draw a polygon here naming A, B, C, D. So this is point A, this is point B, C and D. So you can check opposite side. If I talk about AB, what is the opposite side which do not have any common vertex? First of all, just check what are the vertices with side AB. It's A and B. So you need to take a side in which A and B point are not included. So you can check just opposite to AB we have CD, right? So these are what? These are the opposite sides. AB and CD are two opposite sides to each other. If we talk about now next, if we talk about AD, so this is side AD. The vertices with AD are point A and B. So what is the side opposite to AD? Just opposite to AD, check, which do not include the vertices A and D. That is the side BC. So AD and BC are the two opposite sides. BC is opposite to AD and AD is opposite to BC. Okay, so next in my list is diagonals of a polygon. But before discussing the diagonals of polygon, we will discuss what are the adjacent vertices. Okay, so adjacent vertices are the two endpoints of one line segment. The two points, the two endpoints, two vertices of the same line segment are called adjacent. So in this figure you can check AB is a side and A and B are the adjacent vertices from here. Okay, and next if I will consider the side BC, so B and C, because they are having a common line segment in between, so B and C are also adjacent vertices, right? If we talk about CD, so C and D are adjacent vertices because they are joined with the side CD. So the two endpoints of the side of a polygon, those are called the adjacent vertices. So students, what about non-adjacent vertices? Non-adjacent vertices are those which do not join with the side. They are those who are not the endpoints of any side of the polygon. Okay, so if I'll talk about point A and point D, sorry, if I talk about point A and point C, do they have any side which are joining the point A and C? Side of a polygon, there is no side of polygon which is joining the vertex A and C. So these two are what? These two are the non-adjacent vertices. Now what are the diagonals? If I will join two non-adjacent vertices, so I have taken that A and C are non-adjacent vertices. If I will join these two vertices, this will become a diagonal. Okay. Now there are two more non-adjacent vertices we will talk about. So just see, point B and point D. These two are what? Again, these two are again non-adjacent vertices, right? So if I will join these 2 points with a line segment, point B and point D, so this line segment BD, make sure you are going to write down the line segment name with BD. So BD is also a diagonal. So in this polygon there are two diagonals, AC and BD. I repeat, what are the diagonal? The line segment joining two non-adjacent vertices is called a diagonal. Now we will talk about the names of different polygons. Okay, so first of all, you can't draw a polygon with one side because it will not become a closed curve. It is simple but it is not closed, so this is not a polygon. What about two line segments? Can you draw a polygon with two line segments? Is it possible? Let's check. If I will do it like this or this, I can't make a closed curve. So again, a polygon with two line segments is also not possible. Now a polygon having three sides, again having three sides, it will called a triangle. What is the name of the polygon with three sides? It is a triangle. What is the name of polygon with four sides? It is a quadrilateral. Name of the polygon with four sides is quadrilateral. Then next is name of the polygon with five sides. Here it is polygon with five sides. It is called a pentagon. Next, the polygon with six sides. This is called a hexagon. Okay. The next name of the polygon with seven sides. It is heptagon. It is also called septagon. Okay, septagon or heptagon, one and the same thing. Then what is the name of the polygon having eight sides? Having eight sides, it is a octagon. Having nine sides, it is a nonagon. Nona bachcha hai na ye? It is a nonagon. Okay. Then next, having 10 sides, it is called a decagon. Okay, so I repeat, three sides, it's a triangle. Four sides, it's a quadrilateral. Five sides, it's a pentagon. Six-sided polygon is a hexagon. Seven-sided polygon, it's a heptagon or septagon. Eight-sided polygon is an octagon. Nine-sided is a nonagon. And 10-sided polygon is a decagon. Okay students, so again we will see what are the vertices of these all polygons. I will mark some vertices so it will be more clear to you. Okay, so a triangle having three sides and these are the three vertices of the triangle. Okay, these are the three vertices of the triangle. Then next, in a quadrilateral, these are the four vertices, the corner points where the sides are meeting each other. In a pentagon, there are five vertices. In a hexagon, there are six vertices, right? So similarly, you can check the number of vertices in all, number of sides and number of vertices in all the polygons are same. Okay. Now next we are going to discuss about the adjacent sides of a polygon. So in triangle, in all polygons I will mark only one pair of adjacent sides. Okay, so if I will take like this and this, these two are what? The adjacent sides, because the common vertex is here. Okay, in quadrilateral if I need to take, I can take this and this. There are four pairs of adjacent sides, although in a quadrilateral I am taking only one pair from each polygon. Okay, you can take any. This is just an example to show you. Again here if I will take these two sides, these two are adjacent sides. If I will take like this, these two are adjacent sides having one common vertex. Okay, here I can take this, so these are having one common vertex here, right? Here I can take this. I can take any one. Okay, here this and this, these two are what? These two are the adjacent sides, and this you can take like this. These are what? Adjacent sides. So make sure they must have one common vertex in all. Now next we need to discuss what are the adjacent vertices. Adjacent vertices are those which are having a common side in between. So here this and this, you can see there is a side joining these two vertices, so these two are adjacent vertices here. In quadrilateral if I will discuss this and this, these two are what? These two are the adjacent vertices because they have a side in between. These are the two vertices joining by a side of a quadrilateral. In pentagon, this one and this one, these two are the adjacent vertices. Here also you can take this and this. These two are adjacent to each other. Okay. So all vertices which are joining with the side, these are called the adjacent vertices. Here You can take these two are also adjacent to each other. Okay. Now next we are going to discuss the diagonals. So diagonals are what? Diagonals are the points, line segments joining non-adjacent vertices. So just identify in triangle. Can you draw a diagonal in a triangle? If I take this vertex, is there any vertex which is non-adjacent to this vertex which I have drawn? It will talk about this. This is also adjacent because side is there. If I talk about this, this is also adjacent to the taken vertex because again it is the it is joined by a line. Okay. So if I am talking about the quadrilateral, if I will take this vertex, can you find out any vertex which is not joined by the side? Yes, there is one vertex. So if you will join these two vertices like this will become a, what will this become? This will become a diagonal of the quadrilateral. Quadrilateral have one more diagonal like this. Okay. Now come to a pentagon. You need to just identify, you have to take a vertex and try to identify a non-adjacent vertex we have to take. So identify, here there is one and this is the second one which is non-adjacent to the first vertex. So if you will join this and this will become a diagonal of the pentagon. Okay, there are more diagonals of pentagon. If I will talk about this vertex, it is joined with this and this vertex, but it is not joined with this one. So this is again a diagonal. This is also a diagonal and this is also the diagonal of a pentagon. Okay. Now we will discuss about the diagonals of a hexagon. So if I will take this vertex, it is non-adjacent to this, this and this. So these three are what? These three are the diagonals of the hexagon. So students, this was all about the parts of polygons. So you have to practice all these and you have to think and rethink. You can watch the video again and again and revise. Thank you and have a nice day.